Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video, guys, I'll be tackling the second question, and I'm only focusing on electric circuits. Please do expect a total number of 11 videos, and please note that all of those videos I'll be answering different questions, and all the questions are extracted from past exam question papers. It's very important for you guys to know how to tackle exam like questions. I believe it will give you an edge whenever you write your exam. Let's just get right into it. Learners want to construct an electric heater using one of two wires A and B of different resistances. Okay, they conduct experiments and draw the graphs as shown below. Okay, we can see that, guys, on the x-axis we have the current flowing on the conductor, and then on the y-axis we have the potential difference. Okay, the gradient between the two will give me resistance, because change in y over change in x is the gradient, right? My change in y is voltage, the change in x is current, so voltage divided by current will forever give me resistance. Nah? Okay, the aim, guys, is to find the heater that will be suitable, or rather the wire that will be suitable for the heater. The aim of having a heater, guys, is for us to have more heat inside the room. It's for us to experience more heat energy. Are you together? So the wire that will be capable of transferring more energy will be suitable for the experiment. Are you together? So the first thing we need to do over here, guys, to determine which wire is able to transfer more energy, the first thing we have to do is to find the resistance. Are you together? After finding the resistance of the two wires, we need to check which of the two will give us more power. Remember that power is just equals to I squared multiplied by R. Are you together? So whatever wire that will give us an average power which is greater than the other, that means it will be suitable for our experiment over here. Yeah? Okay, let's answer. Apart from temperature, write down two other factors that the learners should consider to ensure a fair test when choosing which wires to use. Firstly, the length of the wires, guys, must be the same, and secondly, the thickness of the wires must be the same as well. Yeah? Okay, and then now we are told that assuming all other factors are kept constant, state which one of the two wires will be most suitable to use in the heater. Remember that, guys, we want to find a wire that will give us more power. Are you together? The one with the higher resistance will be more suitable. Okay, let's just find that. Nah? Let's first focus on wire A. Let's focus on wire A. Wire A. Nah? The resistance for wire A, we'll find it by simply calculating the gradient over there. Nah? It's simply change in Y all over the change in X. Change in Y over change in X, right? Let's take this point over there. But for me to take that point, I need to know the amount of potential difference I have. There are two numbers between these 10 lines over there, né? And those two numbers are 0.6 and 0.4. If I want to know the value of each line over there, I just need to say 0.6 minus 0.4 divide by the total number of lines over there. We have 10 lines, right? So it simply means that each and every line is just 0.02 apart from one another. Are we together? So That means since I have 4 over there, that means that will be 4.2, and hence I'll have 4.4 there, 4.6, 4.8, 5, 5.2, 5.4, 5.6, 5.8, and then 6. Are you together? So for me to find the gradient, I know that I simply have 4.4 minus 0 all over 0.4 minus 0. I'm taking 2 points. These are the 2 points I'm taking. The x value is 0.4 and the corresponding y value is just 4.4. And the other point is at the origin. I'll do the same thing for, let me just calculate first before I focus on YB. Ne? That's 4.4 divided by 0.4. I'll simply get 11 ohms. Are you together? Which simply means that the average power produced by the first wire, I'll take this current as well. The current is just 0.4 all squared multiplied by the resistance, which is 11. So 0.4 squared multiplied by 11 will simply give me 1.76 watts. This is the amount of energy that will be transferred per unit time. Are you together? Let's see whether a wire B will give me the same power or the power which is greater than that one. Yeah? Do the same thing. Calculate the resistance. Resistance is basically the change in voltage all over the change in current. This is my resistance over there. I mean, that's the voltage. I simply have 2.2 minus 0 all over 0.4 minus 0. And then this will give me 2.2 minus 0 over 0.4 minus 0. This will give me 5.5 ohms. And therefore, the power is just I squared multiplied by R, which is just 0.4, and the corresponding resistance is 5.5. So 0.4 squared times 5.5, this will basically give me 0.88 watts. So this is the amount of energy that will be transferred per unit time. I want to select a wire that will transfer more energy, more heat energy per unit time. So wire A will be suitable because it will transfer more energy. So wire A will be suitable. Now, okay, now let's go to the second part of the question. We are told that in the circuit below, the reading on ammeter A is just 0.2 amperes. The battery has an EMF of 9 volts and the internal resistance R. Let us show the direction of our conventional current. It simply moves from the positive terminal like this. As soon as it gets here, it will split. Why? Because we have our resistors in parallel. So some of it will move to the 11 ohm resistor, and then some of it will move to the 5 ohm resistor, and then it will join there again. Total current will just move. The blue color represents total current, and then green color only represents the current flowing through the 11 ohm resistor, and then the red color represents the current flowing through the 5.5 ohm resistor. Okay, firstly, they want us to calculate the current which is flowing through the 5.5 ohm resistor. You can see the amount of current flowing through the 5.5 ohm resistor without even calculating. Since this resistor is 2 times less than the 11 ohm resistor, it simply means that the current flowing on that resistor will be 2 times more than the current flowing through the 11 ohm resistor. Since the current flowing through the 11 ohm resistor is just 0.2 amperes, that means I'll have 0.4 amperes over there. But since they said calculate, let's calculate, guys, it's fine. There's something we need to know about resistors which are placed in parallel to one another. they have the same potential difference. If I can find the voltage across the 11 ohm resistor, I can simply that means I can simply find the potential difference across the 5.5. Né? So the voltage, let me just call it V parallel because it's the same. V parallel is basically equals to the current flowing through the 11 ohm resistor multiplied by the resistance of my 11 ohm resistor. I simply have 0.2. I was told that this ammeter reads 0.2 amperes. The current is 11. So I have 0.2 multiplied by 11. I'll simply get 2.2 volts altogether. So now I know that for my parallel combination, the potential difference is just 2.2. Remember that the potential difference across the 11 ohm resistor is the same as the potential difference across the 5.5 ohm resistor. So after finding the potential difference, I can simply calculate the current flowing through the 5.5 ohm resistor by saying current is equals to the potential difference across the resistor divided by the resistance of my resistor. That's 2.2 divided by 5.5. 2.2 divided by 5.5, and yes, I do get 0.4 amperes. So the amount of current flowing through the 5.5 ohm resistor is just 0.4 amperes. Okay, and then now they want us to calculate the internal resistance of our circuit. Remember that, guys, we just calculated the current over there, né? But we know that our current will split, so we can simply find our total current. I total will simply be equals to the current passing through the 11 ohm resistor plus the current passing through the 5.5 ohm resistor. This will simply be 0.2 plus 0.4, and then this will just give me 0.6 amperes. Are you together? Now I know my total current. Are you together? For me to be able to calculate the internal resistance, I must know the effective resistance of my circuit. Okay, I just calculated the total current. Secondly, let me go and find my R parallel first. 1 over R parallel is equals to 1 over 11 plus 1 over 5.5. 1 over R parallel. 1 over 11 plus 1 over 5.5. This is just equals to 3 over 11. For me to find R parallel, I need to flip whatever, I need to flip the term on the left hand side. Whatever I do on the left, I must do on the right. So I'll simply have 11.3. I'll simply have 11.3. That's basically 3.67 ohms. Are you together? So my R parallel is just 3.67 ohms. Né? However, my external resistance R external is equals to this resistor plus the combination of my parallel combination. That's 11 plus 3.67, and that will give me 14.67 ohms. 14.67 ohms. Né? Okay, now they want me to find the internal resistance. Né? It will be easy. Why? Because I know that EMF is equals to I, and then I have R external plus R internal. If this is equals to 9, 0.6 is my internal resistance. Né? But if, guys, you didn't want to round off the external resistance, I think it's safer if you do not round off. Let's not round off. We'll round off at the end. Okay, so we are basically adding 11 over 3. What are we getting? 11 plus 11 over 3. We'll simply get 44 over 3 as our R external. Ne? Okay, that's 0.6. We have 44 over 3 plus R. So for us to find R, we must first divide both sides by 0.6. 9 divided by 0.6 will simply get 15. Let me erase this there. The answer here was 0.4. Okay, we'll simply get 15 is equals to 44 over 3 plus small r. Are you together? I am solving for r. I have a fraction. That means I must multiply each and every term by my LCD. Or let me not get fancy. R is just equals to 15 minus 44 over 3. Let me go and punch my calculator. That's 45 minus. So R is basically equal to 0.33 ohms. R is 0.33 ohms. That's how, guys, we're supposed to tackle that question now. And then 8.2.3. Will the ammeter reading increase, decrease, or remain the same if the 5.5 ohm resistor was removed? Okay, excuse me, guys. Once we remove the resistor in parallel, whenever we remove the resistor in parallel, we are basically increasing the total resistance of our circuit. Are you together? And whenever we increase the total resistance of our circuit, the current flowing must decrease, ne? But remember that, guys, here only a fraction of current was moving. But now if we remove this one, the total current will be moving there. Yes, the total current will no longer be 0.6, but it will be a current greater than this. Are you together? It will be a current which is greater than 0.2. So the amount of current flowing through ammeter A will increase. It will never remain the same. Ne? It will increase. Why? Because only a fraction was moving through there. Are you together? Only a fraction was moving through there. But whenever you remove this one, that current over there will definitely increase. Yeah, that's how, guys, we're supposed to tackle that question over there. Ne? I really hope the video helped you out. Just stay tuned and wait for more videos. Thank you.